a fun brain teaser that we're going to work together. We're going to figure stuff out and have some fun. I did want to make a quick mention on the certificate that you have to attend 4 sessions to get that. And then as Alexander was just saying, if you could type in the chat your first name and last name and the word hi, that's going to record your attendance. And at the very end, I'll remind you and we'll type the word bye when we're done. So if everyone could go ahead and do that, that would be great. All right, that looks like everybody did their thing. Dr. Kwon, if you could actually change the settings of the chat. When I open up PowerPoint, that button's hidden from me now. And before we get started, what we want to do is just go around and briefly introduce ourselves to everybody. So Alexander is going to pick on each of you individually, and all you got to say is just, your name. Say, for instance, like what school did you go to, or are you homeschooled? So for example, I'm Connor Pitchford. I go to UCF. I was actually homeschooled in middle school and high school. And then what is something you like? So for me, maybe I say something like, I like playing Minecraft, or, I'm currently reading a book or something, or, whatever your hobby is. I like pizza. So Alexander, if you want to pick out some random people.
Okay, so I'll just go through. So let's start with Aiden.
Hi, I'm Aiden. I go to Indian Trails and I'm a swimmer.
Very nice. Let's do Amal Papali.
Hi, I'm Amal. I go to Sanford Middle. I like playing volleyball.
Very nice. Let's do Andrea Spekla. Sorry if I butcher anybody's names, they can correct me.
Hi, I'm Andrea Spekla. I go to Windermere Preparatory School and I like playing tennis.
Okay, up next we have Andrew Riberick.
Hello, my name is Andrew Riberick. I go to Windermere Prep and I like playing the trumpet.
Oh, cool. Okay, let's do Anisha Guna.
My name is Anisha Guna. I go to Edgewood and I like reading books and playing the piano.
Oh, very nice. Okay. Benjamin Park.
Hi, my name is Benjamin. I go to Windermere Prep as well, and I like reading and playing video games.
Okay, next up we have Brody Asun.
Hi, my name is Brody Asun, and I go to Indian Trails Middle School, and I like playing soccer.
I like playing soccer as well. Next up is Colin.
Hi, my name is Colin. I go to ITMS, and I like playing the saxophone.
Ooh, okay. Next up we have David Alvarez. So it looks like couldn't hear you there. Let me know at the end if you wanted to retry. But if your microphone's having issues, that's okay. And then Diego Alvarez.
Hi, my name is.
Okay. And then next up we have Garrick Spencer.
Hi, I'm Garrick Spencer. I go to Galaxy Middle School and I play guitar.
Oh, cool, cool. All right, next up we have Iris.
Hi, my name is Iris. I go to Trinity Preparatory School and I do photography.
Very nice. Jacob.
Hi, my name is Jacob. I go to Timber Springs Middle School and I like playing basketball.
Okay, very cool. Lenuka Hewagami.
Hello, I'm Lenuka. I go to Hunters Creek Middle School and I like playing chess.
Ah, good. All right, next up, Logan Muller.
Hi, I'm Logan. I also go to Hunters Creek Middle School. I enjoy playing Minecraft.
Cool. All right, and then Matilda Ritchie.
Hi, I go to Winter Prep and I like playing volleyball.
Cool beans. Michael Ligori.
Hi, my name is Michael Agori. I go to the Masters Academy and I code.
Okay, very cool, very cool. Let's see, and then I was gonna call on you, Mike. And then Manaya Amarasekera.
Hi, my name is Manaya, and I like to play and listen to music. I'm also from Hunters Creek Middle.
Very cool. Nyla or Neela.
Hi, I'm Nyla Payne, and I go to Heritage Preparatory School, and I do dance.
Very cool. Let's see here. Next up is Omkar Subramaniam.
My name is Omkar Subramaniam. I go to Edgewood Junior Senior High School and I enjoy programming.
Okay, very cool, very cool. Rafael Ribeiro and then WPS.
Hello, my name is Rafael Stress Ribeiro. I go to the Windermere Preparatory School, and I really enjoy cooking different types of foods, especially new ones I haven't cooked before.
Nice. Okay. Let's see here. And then Rhea Gupta.
I go to Windermere Prep and I like playing soccer.
Okay. Nice, nice. Next up is Ryan Holden.
Hello, my name is Ryan Holden. I go to Windermere Preparatory School and I like playing lacrosse.
Oh, neat. Okay. And then Saifullah Pervez. I tried.
Hi, my name is Saifullah Pervez. I go to Hunters Creek Middle and I like donuts.
Oh, nice. All right. Let's see here. Shea N. Or Shay. Okay, looks like your mic had some issues. That's okay. Then we had Shreya.
Hi, my name is Shreya. I go to Edgewood and I enjoy reading.
Okay, very cool. Simon G.
My name is Simon Gong, and I like to swim and play the piano.
Okay, very cool. And then Tanvi Koneru.
My name is Tanvi. I go to Windermere Prep and I like to do art.
Very cool. And then Yusuf or Joseph.
Hi, my name is Yusuf. I go to Hunters Creek Middle and I like playing video games.
Very cool. And then right at the end, David Alvarez says he fixed his microphone. So if you want to try introducing yourself again, that's fine.
Hi, my name is David Alvarez. I go to Melbourne Central Catholic and I like playing basketball.
Cool beans. All right. So aside from the mic issues, that's everyone. So everyone's had a chance to introduce themselves to everyone.
All right, cool. So the idea of today is I'm going to pose open questions to you, and the answer might not be obvious, right? And so the idea is I'm going to give you a question, and you're going to try to figure out patterns and ideas on your own, and then we're going to come back together and see what we came up with. So for example, hold on a second. All right, you guys can see my screen, right?
Yeah.
All right, cool. So, so for example, we say, what is common in the following numbers? 1, 4, 9, 16, 25, and 36. So if everyone wants to just take a moment and try to figure out any type of pattern that they see, and you can feel free to, once you have your answer, whatever you think it is, you can send us a chat to any of us, any of the teachers. All right, cool. So what I want to go ahead and do is just share some of the answers that everyone has been, typing into me. And so what I'm seeing is a few different ideas. So we have people saying that they're perfect squares, which is correct, right? But it's a correct answer. There's no wrong answers here. So 1 is 1 times 1, 2 is 2 times 2, 9 is 3 times 3, 16 is 4 times 4, 5 is 5 times 5, and 36 is 6 times 6. So that's one possible thing I've seen people saying. Someone else said that there's the pattern of odd, even, odd, even, odd, even. That's definitely a pattern, right?
And then someone shared a very interesting thing as well. Would the person, okay. So David Alvarez, would you like to unmute yourself and share the pattern you noticed?
I noticed that it went from, can you hear me?
Yes.
Okay, yeah. So it first started 3, and then it went 5, 7, 9, 11.
As far as what was being added. Yes.
Yes, very good observation. Plus 3, plus 5, plus 7, and so on, right? Plus 9, and plus 11. All right, and that's a good introduction of what we're talking about when we're looking at these problems. Different people are going to come up with different answers, and that's okay, because what we're trying to do is try to move through these ideas and get to certain conclusions, and we'll see what happens. And like I said at the beginning, if there's some of them that you're like, man, I don't see a pattern, I don't see an answer, that's fine. Some of these are, some of them are easier, some of them are harder. Someone asked if it's okay if they leave for a moment to get a notebook. Absolutely. You're definitely going to want some paper or a pencil or pen or something for this. All right. Someone else pointed out an interesting one. They're saying that if you square root the 2 previous terms, then add them together and then square that number, you get the term. So it looks like if we square root the 1 plus the square root of the 4, and we add them together, and then we square them, they're saying that we should get the 9. And that's right? This becomes 1 plus 2 squared. This is 3 squared, and that's 9. Now that's an interesting pattern.
What about the 4 and 9?
Do you want to see if it keeps going?
Yeah.
Yeah, why not? 4 plus 9 squared, and this would give us 2 and 3. That's 5. Uh-oh. A little bit of an issue, right? With that pattern. The 4 and the 9 does give us another answer, but it jumps all the way. It skips the 16, right?
That pattern would hold true if instead of the square is increasing by a square of increasing by one number, so it's 1 squared, 2 squared, 3 squared, that pattern would hold true if it was squares of the Fibonacci sequence instead. So it was 1 squared, 2 squared, 3 squared, 5 squared, 8 squared, and then I think 13.
Alexander, you know that off the top of your head?
Not off the top of my head, but I think I know what you're explaining, and I think it's correct. Could you repeat it just a little bit slower, perhaps, then we can write it out so everyone else can see this pattern?
So the sequence shown was squares of numbers just increasing by 1, so it's 1, 2, 3, 4, 5 squared.
Ah, yes.
That
okay.
pattern stated before would hold true if it was instead squares of the Fibonacci sequence, as in 1, 2, 3,
okay.
5, 8, 13.
So if it was a different sequence that we had given you to start with.
Right. So if we had a different sequence, then that other kid's pattern would correctly, work out. Awesome.
Yes.
Yeah. So there's all sorts of interesting patterns we're going to note today, and things that other people are going to see that you didn't see and everything, right? Like personally, this idea here, I probably never would have saw that, right? So it's going to be an interesting day. Specifically, though, we want to go ahead and focus on those perfect squares. And so just to give a quick formal definition, we say an integer n is a perfect square if n is equal to some k squared. But specifically, don't let these letters mess you up or confuse you or anything. So the letter n is just using to represent some unknown number. So on our previous page, this n could just be the 1, the 4, the 9, the 16, the 25. Right, just those n is just some perfect square. We don't know what the number is yet. It's some unknown. And then we also put a little restriction on the k, and we say that k is a natural number. So k can be something like 2. That's okay. But k should not be something like 2.5. Right, we only want those positive whole numbers. Is there any questions on that before we move on?
No.
No.
Okay, cool. So let's visualize our ideas of these perfect squares. So I've got pictured here a blue dot. It's just one dot, right? And it's 1 by 1. It's 1 dot tall, 1 dot wide. And then we have in the green, we have 4 dots. And so what we can do is let's just rearrange them. And then we can see that this 4 is 2 dots by 2 dots. And we could do the same idea with the 9 red squares, right? If we rearrange those, then we see that it's a 3 by 3. And that's exactly what we expect, right? Because we want 3 times 3 to be 9. And similarly with the yellow dots, we see the same pattern. That if we rearrange the 16 yellow dots, we get a 4 by 4 pattern here. All right, so now with that in mind, I want to introduce another idea. Like, all right, we've rearranged these. Now, what if I rearrange them again? Is that going to introduce you a type of pattern that you can be able to see? And so just rearranging these real quick, what if I drew a line like this? Onto that square, right? And let's say I do the same thing for the number 9 with the red circles. So if I draw a couple more lines on it, we have it like this. And we'll do it the same for the yellow. And in your imagination, keep going. Like, what if we had, instead of 16 yellow squares, we had 25 purple circles or something, right? So take a moment, same thing as before, try to come up with whatever pattern that you see going on here and see if we can reach some type of conclusion. Oh, and feel free to send it in the chat whenever you have got it figured out.
You can send your ideas to me, Connor, or Maria, or Mike, and any one of us may share anything or bring to attention anything that looks particularly out of left field or surprising as a pattern.
Yeah, Mike is not the co-host.
Oh, okay. So then,
yeah,
Connor or Maria.
All right, so it looks like, at least the chats that I'm getting, it looks like everyone is saying basically the same thing, that we're looking at this and we have 1 and then 3, and then the next one has 1 and 3 and then 5, and this one has 1 and 3 and 5 and 7. And so each new row or section, maybe I should say, each new section is increasing by 2. And so we're going 1 to 3 to 5 to 7, and each time it's plus 2, right? And someone actually pointed it out. That it's an arithmetic sequence, right? We're going to go into that a little bit. See someone point that out. Lots of people saying each one increased by 2. That's what we're talking, that's what we're talking about here. Oh, all right, we got a good one. Someone pointed out that said that any particular k squared consists of k sections. So they are saying any k squared has k sections. And so far, it looks like this that's a true statement, right? If we're looking at this, this is 16, which is 4 squared. And if we look at this, we have 1, 2, 3, and 4 sections. Alexander, Maria, did either of you guys get anything else worth mentioning that's different from this?
So one person commented on what this means and what this is now equal to. So I'll invite Simon G, if you want to unmute yourself and share what you wrote to me.
I said that this means that every perfect square is equal to the first n consecutive odd integers.
Now, very good. I would like to ask, does anyone else want to clarify the meaning of consecutive here? Does everyone know what consecutive means?
Yes.
Okay. Is there anyone who doesn't know? Okay. Okay. So Connor, take it away.
All right. And that's actually the pattern that we actually, let me back up for a second. And what I think he said it was Simon. What Simon was talking about is, what we're trying to go for is that these perfect squares are the summation of consecutive odd integers. And so we see that this 16 here, right? This is the same as that 1 plus the 3 plus the 5 plus the 7, where we have each of these groups here in the yellow. You can see each of these groups. And so with this in mind, we can use this for any large number or small number, just any perfect square number. So for example, we could say that 81 is a perfect square, as 81 is equal to 9 squared. And this means that we can express 81 as the sum of the first consecutive odd numbers. Now, what do we mean by first consecutive odd numbers? Basically, what we're saying is that it's consecutive, meaning that it doesn't skip any odd numbers. So it does not, so something like 1, 3, 5, 7 is good. We can't say 1, 3, 7 because we skipped the 5, right? And when we say first, that's just meaning that we're starting at the number 1. So 1, 3, 5, 7 is perfectly fine, but 3, 5, 7 is no good because it doesn't start at 1. So with this in mind, on your own, try to see if you can write out 81 as the sum of the first consecutive odd numbers and see what you get. And then we'll, same as before, do it on your own, send any of us the chat, and then we'll regroup and try to see what everyone got.
Wait, what are we supposed to do?
You're going to try to write 81 as the sum of the first consecutive odd numbers. So we're wanting to write 81 is equal to 1 plus 3 plus something. Right.
Okay, so I'd like to, okay, good. I'd like to try to call on some people. So let's give it just a couple more minutes, and then I'm going to, not to strike fear, I'm going to pick someone who I don't believe has spoken yet. And if you don't know when I call on you, that's fine. Don't be ashamed. I usually don't know the answer to things.
Also, don't be afraid to ask questions. If you don't understand something and need clarification, go ahead and message Alex, me, or Connor for that extra explanation.
Okay, so Logan Muller, would you be, do you have any idea how far out we need to add here? What would be what we're adding to 1 plus 3 plus etc.?
I believe you need to get to 17.
Very good. And would you be willing to share how you know that that's where you need to stop? I'm assuming you didn't just add them, right? If you did, that's fine. But did you do something sneakier to tell that that's where you need to stop?
No, I just added them.
You just added them. Okay, that's fine. That's fine. So now everyone has heard me ask that, and they know, wait, there's something sneakier going on. Would anyone like to volunteer, preferably if you haven't spoken yet today, especially, would anyone like to volunteer the sneaky way to tell that 17? I see that Michael put their hand up in the chat, so go ahead.
So if you take the square root of 81, you get 9. So you find out that, and that the pattern is that that 9 is the amount of consecutive odd integers that you need to add.
Correct. Very good. Very good. And I noticed there were other people who had their hand up. Yes, Colin, would you like to add or clarify on that?
Well, if you didn't know that, there's also another way you could do it. So you do, since it's consecutive odd numbers, you can find actually, never mind, actually you have to know that.
Okay, actually,
I have something to add.
Okay, 1 second though. If you don't mind, even if you've noticed that it's incorrect, would you be willing to finish that train of thought just because it might be illuminating to others?
Well, I mean, I was just thinking that you could do 9 times 2 minus 1, and you'd find the last numbers. Right.
No, good. Yeah. So that's why I encourage you to share it. Connor will elaborate on that in a minute, but actually that is kind of on the right track. And again, I'll save that for when Connor gets to it.
Yeah.
Who else was trying to comment just a second ago?
Yeah.
That's actually exactly what I was about to say, is that
Okay.
whatever odd number you stop at is 1 less than twice the number you want to square.
Excellent. Yes.
Yep. And that's a great point of why we do want you to express your ideas, your thoughts. So sometimes you might think, oh, no, I'm wrong. But actually, you're right. You're exactly right. This last number here is 2 times our number minus 1. Or in our case, this is 2 times 9 minus 1, 18 minus 1, which is 17. And that pattern does hold true for all of them. Right. We already went over this. We said that there is a pattern, right? There's going to be 9 pieces. So in general, we can write this out we can say that if we have n, which is equal to k squared, again, n is just our perfect square, k is some whole number, positive whole number, then n is equal to 1 plus 3 plus 5 plus ... It keeps going until we get to that 2k minus 1, exactly as he just said. And as we were talking about, this means that we have k pieces. Or, we could say, or we could call this k consecutive odd numbers. Does anybody have any questions on this? Like, does the 2k minus 1 make sense?
And please keep in mind, there's a tendency once a few people have said like, no, it makes sense, everything's good, where if you don't feel you get it, you'll tend to not want to say so. Please do if you have any trouble understanding or you would like a repetition of any of the ideas that we're expressing here, please say so. All of the people I admire have been people who are not afraid to admit when they don't understand.
Yeah, and I will expand on that a little bit. When we teach classes in person, and we'll have like 100 students in one class, and we're helping all of them out. 90% of the time, like 10 students will have their hands raised, and they all have the exact same question. So if you have a question, it's very likely that there's a few other people in the class that also have that question, but they're either too nervous or they're afraid to speak up, and that's very common. So I mean, don't feel free to ask questions or anything. It's all good. All right, so let's try this again. A different sequence: 1 plus 3 plus 5 plus 7 plus, keep going all the way up to 21. But this time, try to do it no calculator. Just do it pen and paper.
And another way to say this, right? So when Connor says use pen and paper, we don't mean, oh, so on pen and paper, do 1 plus 3 and then add 5 and then add 7. Math is kind of the art of
That's a good point.
Yeah, math, believe it or not, right? Especially if you're kind of on the fence about math. I hope all of you love math, but if any of you would not say it that strongly, math is actually the art of being as lazy as possible, right? I am too lazy to sit down and add all of these. Is there a sneaky thing we've been looking at that you can use, which we've been doing, to do this quickly with low effort, where even using the calculator is too much work? What's the easy, lazy thing you can do here?
Andrew, do you have your hand up? Do you want to go ahead and use your mic and speak?
Yeah. So what I did is, so we had the formula from earlier, 2k minus 1. So you just solve for k. What?
Solve for k when it's equal to what?
10.
Very good. Okay.
Sorry, when it's equal to what?
10.
So why 10?
Well, okay. So 2k minus 1 equals 21. So if you add 1 to both sides and then divide both sides by 2 after, then k will be equal to 10.
You have the perfect process. That is exactly what you want to do. So what you did is you set it equal to the last term, right? And then you solve for k. That's perfect. The only thing is, when you add 1 to both sides, what do you actually get on the right-hand side?
No. The answer is 11.
There you go. Yeah.
There we go. Yeah. And I will say personally, that type of mistakes are like the bane of my existence, where you say like 21 plus 1 and you end up getting 20 or something. And like, the right process, you just make a little goof up. And like, I've gotten so many things wrong because of that type of stuff. All right. So we got k is equal to 11. Does someone else want to, what are we doing now? What does k even mean?
It's the number of terms in the sequence.
It is the number of terms in the sequence.
And then it's consecutive odd numbers, so you just square it. too.
Yeah, and like you just said, so we can just square it, because you remember that our perfect square n was k squared. And so we can find out that the sum of all these together is 121, which it looks like most people got 121 in the chat. If you got something else, you can definitely feel free to share how you got that answer, that we can see, like, what were you doing? Or if, that makes you a little nervous to share something that you did wrong, that's perfectly fine. We can just call this good.
I will take a moment to just kind of emphasize to everyone again to notice now, sometimes when me or anyone else starts talking about, here's what math is about, and we start saying words, right? And it can sound like, yeah, whatever, I'm going to calculate something. So now that you've seen it, think about what I was saying earlier about math being about being as lazy as possible. If you didn't see this, that's okay. But now that you see it, now that you've seen it done, look how easy that is. Just, oh, last number, there's 11 terms, square it, I'm done. Compared to this, even getting a calculator and punching them in feels painful and tedious, right? This was so fast and easy.
Yeah, and it's way more extreme because we're talking about a small number like 21. What if your number is 605 or something? Or that's not a perfect square. Something like 625. Then, that's a lot of numbers to punch in a calculator. All right, so if you didn't get that one, let's try another one. What is the sum of the first 35 consecutive odd numbers? This is what we're talking about. 35 is a lot more to punch in. You can use a calculator though, because some of these numbers are a bit large.
So being lazy to see what you need to do, wink, you can then use the calculator, but please don't use the calculator to do 1 plus 3 plus 5 plus 7 for 35 odd numbers, right? Just because no one wants to do that. That's too much work. I already have gotten some answers, but let's wait a bit and then I'll pick someone who I don't believe has spoken yet to share what they got.
All right. We're gonna get the right answer also eventually, but I'm also seeing quite a few of the same wrong answer coming in, and so I definitely want to check that out at some point also.
Yeah. So let me go ahead and I'll just go by first person that I don't think has spoken yet. So Amal, would you be willing to share your answer
Yeah.
and how you got it?
So it's 35 numbers, k squared, 35 squared, which is 1,225 because 3 times 4 and then ending in 25.
All right, so just in case you didn't catch that, he's saying that there's 35 numbers. That means that is our k value. And since n is k squared, that gives us 35 squared, which is, what is that, 1225?
1,225. Yeah.
Yeah. Now, if the answer I saw a lot of people say is 324, if someone who answered that wants to volunteer what they did to get that process, that'd be great, just for my own curiosity.
Wait, I didn't get that answer, but I think I know how you would get that.
All right, how?
Maybe they're thinking the first 35 consecutive numbers.
So not consecutive odd.
I think they might have been thinking
Never
that
mind.
35 was the odd number you stop at instead
so
of
it's
the
like
first
2K.
35 consecutive odd numbers.
Okay.
Oh,
Would anyone who got that like to share? Did you do 35 equal to 2k minus 1 and try to solve for k? To anyone who got that value? So we're aware that, especially once you know the answer is wrong, there's a hesitation. There is a
Mhm.
lot of very interesting stuff from world-class mathematicians that comes from them having made a mistake and then accidentally finding other patterns. So if I am not wrong in front of people at least once a day, I don't think I've been brave enough or thought hard enough about things. So again, want to develop not just your math knowledge, but you want to be willing to make mistakes in front of people and share the reasoning behind those mistakes, because being a mistake is contextual. Maybe it won't be a mistake in some other situation, and you can use this new tool you found. By doing the wrong thing here, you can use it somewhere else and it will be the right thing. So, okay.
And we already saw this today, right? Someone pointed out the 2k minus 1 pattern before we had talked about it, and then they started to quit talking about it, right? Because they were like, oh no, I think I'm wrong. But they were right. That was like the legit thing.
Yeah, so just to emphasize, because Colin was right, this does give 324. The wording is important, right? And for a lot of people, that's what's going to be difficult in math, is when the question is all words and you have to translate. So let's make if Connor, if you're fine with this, let's make the number a little bit smaller. If you notice, when we had the first 9 consecutive integers, that did not go 1 plus 3 up to 9. It went 1 plus 3 plus 5 all the way up until 17, right? So the first 9 odd numbers didn't mean that the last number was 9. Similarly, the first 35 consecutive odd numbers doesn't mean the last number is 35. So that's a subtlety in the wording you've got to be careful about. Have you given me the last term, or have you told me how many terms there are? Does anyone have any questions or clarifications on that difference? There is a question in chat I'll share. I'll keep them anonymous, but so they thought it meant to add, it meant all the odd numbers added until 35. Okay, and so that's what we were just saying, right? The first 35 consecutive odd numbers doesn't mean go until you hit 35. It means list them until there are 35 of them. So again, as Connor wrote, there's a list of 9 odd numbers. Goes 1, 3, 5, 7, 11, 13, 15, and 17. There are 9 of them, but the last one is not 9. I noticed that Brody has his hand up. If you'd like to comment or anything.
Oh, sorry, that was from the previous question.
No worries.
No worries. All right. If everyone's good, though, we'll look at another problem, see what we can do. All right, this one's a little different. This time we're saying, can you express it? Is it possible to express 196 as the sum of consecutive odd numbers which start at 1? Why or why not? To make it a little extra challenging, don't use the calculator.
Excuse me?
Sorry, what'd you say?
Wait, should I say the answer or like?
Oh no, if you've got the answer, go ahead and send it to us in the chat. And that way we can give everyone a chance to figure it out on their own. Now, if you've got the answer and you want to be called on, we can definitely do that once everyone's had a chance.
Now, just as a response to some of the messages I've already got, remember there's 2 questions. There's kind of 1, maybe 2 questions, right? Can we do it? Why or why not? So you can give us, if you're able to do it and you want to give us like some numbers relating to it, cool, you can. But notice the question doesn't actually ask for that, does it? It simply asks, can you do it? And if not, why not? And if yes, how come?
Right. All right, and this question has a little hint. I'm seeing some people get the right answer, but if you want a little hint, you could perform prime factorization or make a factor tree.
Would you like me to call on someone, or do you want to do it, Connor?
Andrew, do you still want to say what your answer was?
Sure. I said that yes, it is possible because 196 is a perfect square, and as you demonstrated earlier, perfect squares can be split up into perfect squares are equal to a sum of consecutive numbers, a certain amount of consecutive numbers.
Consecutive odd numbers, but yes.
Yeah.
All right. So just as he was saying, yes, because 196 is a perfect square, and because it's a perfect square, therefore it can be added as the consecutive odd numbers to start at 1.
And by the way, those dots that Connor wrote down, that actually is math speak for therefore. So we might sometimes throw symbols at you may or may not have seen just out of habit. So now you know that actually means therefore.
Yeah, and this is also a little bit more what Alexander was talking about with mathematicians being lazy. It's not just finding the easiest way to do the math. We are even lazy when we write.
Yeah, I don't want to write a word. I could just go da, 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 and move on with my life, right?
Does anyone else have anything they want to add to this? All right. What we were talking, I do want to look at this hint real quick. What we were talking about with the prime factorization or making a factor tree. 196 might be a number that you actually recognize as a perfect prime just off of your previous experience. But you might get a number that you don't recognize. You know, you may not actually know whether it is or not. And so what we're talking about making a factor tree is we say 196. We can split this apart. This is the same thing as 2 times some other number. I'm using the number 2 because it's even, right? So I know for a fact that a 2 goes into it. And this is the same thing as 2 times 98, right? Same thing with the 98, it's even. So I know for sure that a 2 goes into it. And so 98 is the same thing as 2 times 49. And I know this isn't Alexander's favorite way to do this, but and 49 is the same thing as 7 times 7, right? And so we could say 196 is the same thing as 2 times 2 times 7 times 7. And that's good. And I'm going to do one more step in between just so we're really clear, right? This is the same thing as 2 times 7 times 2 times 7. And this is 14 times 14. And now we see that 196 is 14 squared. Now, this may not necessarily be true if you're doing some other number, right? So, you know, what if let's just pick out a number, let's say 20, right? So if we did something like 20, 20 is the same thing as 2 times 10, which is 2 times 5. And so we see that 20 is the same thing as 2 times 2 times 5. There's no way to group that 2, 2, and 5 together to make 2 of the same number, right? So this would be a case of a number that's not a perfect square. But this is, the factor tree is a nice little thing that you can do for really large numbers if you're trying to break them down into bigger, smaller pieces without knowing what they are. All right. Here's another question. So what is the sum of the odd integers going from 1 to 100?
And again, be lazy, right? You could do 1 plus 3 plus 5 plus 7 and go into, but that's so much work. Be lazy.
Yeah, and I know I've said this a couple times. I'm going to say it again. Again, it's okay if you don't know the answer to all of these, or you know there's some of them that you can't solve or whatever. that's fine. The idea is this is just a fun brain teaser. Hopefully you can get all of them. If you don't get some of them, that's perfectly fine. Expect to get some wrong answers, right? Some of these aren't easy.
And let's just wait a little bit longer, but I will tell everyone that this is actually a famous question. So after we discuss the answer, can explain why. Oh, actually, it's related to a famous question. Okay, I feel like I've been calling a lot. So Connor, do you want to call anyone?
Yeah, sure. Right. Jacob.
Okay, so it's asking the sum of the odd integers from 1 to 100. So obviously 100 is not an odd integer, so it'd be 1 to 99. And then if you do the 2k minus 1 thing, so it'd be 99, which equals 2k minus 1, so it'd be 2k equals 100. And then so k equals 50, so it'd be 50 times 50, which is 2500.
Yeah, awesome. Now, again, I know that there's going to be people hesitant to share because I got the wrong answer, but I did see a common answer of 10,000. And if anyone wants to share where they got that.
Excuse me, I have to leave, but thank you.
Okay.
Yes, yeah. Bye.
Bye.
I think some people may have gotten 10,000 because they use all of the consecutive integers instead of just odd consecutive integers, and 100 times 100 is 10,000.
All right, that could definitely be a theory. And that's also something kind of interesting with math also, is that you can also try to figure out where other people went wrong, and that can sometimes expose new things. Michael, you got your hand raised. Feel free to say what you got to say.
I think they may have just squared 100.
And just went straight to it, no formula or anything, just.
They might have said, yeah, so they might have said 1 to 100, like he said, like said. So they're like, okay, there's 100 integers. So then it would be 100 squared, which would be 10,000.
And it's good to note that if the let's see, what would the question have said in that case? So if the question had said, what is the sum of the first 100 odd integers? Then 100 squared would be perfectly correct because we want to take the first 100 odd integers, add them all up. That would be 100 squared. But that's not what the question says, right? The question says the odd integers from 1 to 100, meaning, but for all the numbers in between 1 to 100, all of those odd numbers, add them. So that would be 1 plus 3 plus 5 plus 7 plus 9 plus 97 plus 99, right? That's all the odd numbers in between 1 and 100, right? So there's a lot of grammar involved too in some of these more interesting math problems, right? Where you have to be very careful of exactly what they're asking and the precise wording. And of course, it's perfectly fine to ask for clarification here. And in the future, almost all of the time, that type of clarification is fine. Even during, like, say, an exam or something, you can go, excuse me, I just wanted clarification. Do you mean this or this, right? Based on the wording. That is an okay confusion to have, because that means you are getting correct answers, just correct answers to different questions, but they're still correct answers. As long as you're thinking and you're thinking about what you're doing, that's awesome.
Yeah. That's actually a really good point Alexander just made, that this 10,000 is the correct answer. Just the person had the wrong question in mind. You know, they incorrectly read the question. All right. All right. Let's go ahead and do one more of these type of problems. Just try to make sure everyone's got it, you know, cemented in.
Wait, was 10,000 the correct answer?
No. Going back, if the question had said in the yellow here, what is the sum of the first 100 odd integers, then 10,000 would be the right answer. But the original question was saying, what is the sum of the odd integers from 1 to 100, which is only going from 1 to 99.
Yeah.
And there's 50 of those, right? So actually, one more point, the 2k minus 1 equals 99. We were able to get k equals 50. Make sure to always know what your numbers mean, right? Because it's easy to turn into a robot and just like calculate, like, okay, well, the formula is 2k minus 1, k equals 50, k squared, I'm done. Okay, but what does it mean? It means that there are actually 50 odd integers from 1 to 100. That's how many there are. So the sum of the first 50 odd consecutive integers is 50 squared is equal to 2,500, right? So in general, if you want to be, if you're like, how do I get really good at math, right? I see people are really good at it. If you can always write what you're doing, what it means in English or in any language, in words, that probably terrifies a lot of you who lean more into math, right? And may not be a big fan of writing. But actually, if you can write in plain, whatever your favorite language is, in words, what these things mean, that's one of the best ways you can become a very good mathematician or a person who's very good at math.
All right. We're going, like I said, we'll look at one more of these type of things. Then we're going to go look at a different type of problem. What is the sum of 1 plus 3 plus 5 plus ... plus 179 plus 189? And this is what we're talking about earlier. Getting into some fairly large numbers. Putting this on the calculator is not really the thing.
I want to make one clarification. Is the second to last number supposed to be 179 or is it supposed to be 187?
Oh, that's a very good point. that last number should indeed be 187.
Oh, no, actually it's this number that's messed up.
Sneaky,
Oh, okay.
sneaky. Okay.
Yeah, that is my bad, guys. I made this document and looked at it a couple times and never even saw that.
Although very quickly at the end, so we'll wait a bit since we had to fix that for everyone to redo it. Right at the end, there is actually a way you could do what was written there. You just have to be able to think about it.
Yeah. On that note, why don't we stick with the how it was written?
Yeah.
Well, yeah.
So,
yeah, it'll be fun. Why not?
Cool. There's a way to do this. Again, be lazy. What do you need? So don't say it out loud. Just think about it. Huh? Why is this still okay? What do I need to do to make this work?
Not sure if lazy is the answer, but is there a shortcut?
Right. Well, lazy is not negative.
Lazy can mean different things to you and I.
Yeah, when we say lazy, you should still get the answer, right? We're just saying do it in the most optimal direct path without cheating, right? Like don't cheat.
Don't even consider cheating.
All right, cool.
Do you want me to
I think that might be enough time. Yeah, sure.
Okay, let's do, okay, I don't believe Erica Kim has had a chance to speak today. Be willing to share what you did?
Can you hear me?
Yes.
Okay, so I did the 2k minus 1 equals to 179. I forgot about the 189 for a second, and I just did 2k minus 1 equals to 179, which is also equal to 180, which then you divide by 2, which equals 290. Then I did 90 squared, which is 8,100. Then I looked back at the 189 and I just added the 189, which will make it equal to 8,289.
Excellent. Does anyone have questions on what just happened with this problem and what was done to make the formula work when it appeared to break?
Yes, how does it work? I understand how the process is, how you add it at the end. I just don't make it work.
Okay. Connor, do you want to go for it?
Yeah, so what we've got going on here is going from this 1 all the way up to this 179. Our normal formula works, right? This is a consecutive odd integers, right? And then we have this uh-oh moment, right? Where there's something, it breaks, right? That is not the next consecutive odd integer. But the idea is we could still use the formula for this green section, and then afterwards just add the 189 on. Just treat it as 2 separate pieces. Did that make sense?
Yeah, it makes sense. Thank you.
All right, cool.
And notice how we could make it really weird, right? We could have actually added anything there or subtracted anything there.
Yeah, maybe we have
right,
whatever, right? All right, that was actually a really good accidental question.
Let's just say happy little accidents, right?
Yeah. Now I did see a lot of people say 9,025. If again, I don't want to call out someone who got the wrong answer because that makes some people a little, but if you want to volunteer, and tell us how you got that, or if someone thinks they know how everyone was getting that, that'd be great.
I got 9,025. That was another mistake, but I just kind of assumed that I didn't really like pick up on the fact that 179 is not a consecutive odd number with 189.
So
right.
As fast as possible.
Very nice. Yeah. So that's actually good because that's not any misunderstanding of that's just, oh, whoops, I didn't notice because that came out of left field and was actually a mistake on our part with the slide, right? So you just did if it had been like 187 and you did the sum of those first odd integers. So yeah, that makes total sense.
I will say that's also a really common thing that can kind of trip students up, or anyone doing math, is you get in a rut. You're like, I do A, B, and then C, A, B, and C, A, B, and C, and then you don't realize that the question changed and now it's A, B, D, or it's something else. But now that it's A, B, D, you still did C anyways, because you get in that mindset, the tunnel vision where you're used to seeing what you see, and something else just. At least I do. I mean, I'm assuming,
Oh, yeah,
it's true for other people too. All right, cool. So that's probably where that 9,025 came from. Let's look at something a little different. We talked about this formula breaking. Let's break it a little more, right? So what if we have this? We don't start at 1. We have the sum of 35 plus 37 plus 39 plus ... going up to 175 and 177. And note, there are no issues this time on this side.
On this side?
On this side. This side, however, we got, uh-oh. So everyone take a moment, try to figure that out, what you want to do with it. And this is definitely probably one of the more tricky ones that we've done tonight. It's, it's a little different. It's a little bit of a brain teaser. You're gonna have to think about it for a second and try to figure out what it is. But I think once you realize the trick, so to speak, you'll be like, okay, that's not a big deal. All right, I've got a couple answers came in that were right, a couple wrong answers. Does everyone need more time, or would you maybe want me to give you like a little hint, or we can just dive into it?
I think we're ready to go.
All right, cool. Do we have a volunteer? Anyone who wants to say how they got the answer?
Can I chip in?
Yeah, go for it.
So I did the normal problem as if it started from 1 and got 7921, and then I did from 1 to 33, and then subtracted the number I got. So I plugged the 33 into the problem.
Awesome.
17 squared, and then subtracted 17 squared from 177, or whatever 178 divided by 2 was. I forget. But I ended up with 7632.
All right. So if you didn't catch that, what he was saying is that our original sequence is the same thing as the big sequence, the entire thing. And if we subtract the first part of it, and then so if we subtract all the numbers from 1 to 33, that has to leave us with the original thing. And now that we have two sequences that do follow our rules, we can use what we know. And so we can say that we have 2k minus 1 is the 177, 178, and we get k is, what is that, 89?
Yes.
And so that tells us that this number here is k squared, and so that is, as he said, 7921. So that's for this one. I'll grab a different color real quick, so I'll keep these separate. And we do the same thing for this one. 2k minus 1 is 33. 2k is 34. K is 17. And so then we can subtract the 17 squared, which is 289. If we combine those together, that gives us a total of 7,632. See someone raise their hand, go for it.
Yeah, Amal?
I had a different method. You didn't teach it yet, but like I did it differently. I figured out the average of the numbers multiplied by the number of numbers. So the average was I'm pretty sure it was 106, and then the number of numbers was 71, and then multiply that, and then you get 7632.
Yes, yes.
Gotcha. Nice.
So he took the average of all the numbers, which is 106. He multiplied them by the number of numbers, which was, what do we have? What did you say that was?
72.
72. Plug that into our calculator and we get the same answer. And this is one of the things I love about math is there's multiple different ways to get the same answer. And I don't know, to me, that's great. You're not stuck trying, with only one possible solution.
Notice also Anisha has her hand up. Want to share?
Yeah, so I actually got the wrong answer, so I don't know if I messaged wrong or I did an arithmetic error. But
okay.
So like what I did was I subtracted 34 from like each number, so it got like made the 35 into 1, and then I subtracted from 177, and then I used the same method, the 2k minus 1.
Very nice. Very, very nice.
Okay.
See, and that's what I'm talking about. Like for me, I immediately went into the blue route that we have written here. That was what I thought was like the most obvious for my brain, at least, right? But you said that, and that is just like beautiful, amazing. Like, so we subtract 34 from all of these.
And there's 72 of them, right?
Yeah. Now,
okay.
Yeah. Now, you do run into a little issue that you have to fix it later, which is probably why you got the wrong answer, because you subtracted 34 from each of these numbers, right? Which means your answer is missing 34 for each of these answers, for each of these numbers. And so at the end, whatever you get, you say you get star or whatever, right? You're going to need to add back on 34 times your how many numbers that you have, whatever your new k value is, and that will bring you back up to the 7632.
So double check
Yeah,
it.
that's what I did.
There you go. So doing her technique of minus 34, what this becomes is basically what you get 1 plus 3 plus all the way up to 143. And you can then do 2k minus 1 equals 143. Get your k, square it. And when you're done, what you have to then do is add on all of those 34s you subtracted. You just have to add them back. So what this gives you, you would then add 34 times 72. So like if explicitly k equals 72 for what Connor has in green, so k squared is 5184, and then you just do that plus 34 times 72. And the reason me and Connor are excited about that one is because that's so out of left field. I don't think I would have come up with that. And it is correct. The only reason that you got a wrong answer was just missing a step, but the idea was correct. And so that's very creative and cool. I noticed someone else had their hand up, but they ran away. Come back if you have a question.
I do have one person who's still a little confused about the first method in which we used. So I don't know if you want to explain that with the 1 plus all the way 177 in blue.
Yeah. So Connor, if you want to reiterate that.
Yeah. Let me grab a different color real quick. So this was our original thing that we were saying, the 35 plus ... going all the way up to 177. And the issue is that we can't use our formula unless the number starts from 1. And ours doesn't, so that's no good. But what we do is we say, let's start a sequence from 1 going to that 177. And that's good because our sequence now starts at 1, so that allows us to use our formula. But it's bad because we have a bunch of extra numbers now, right? We don't need the number 1, 3, 5, 7, 9, going all the way up to 33. Those are all extra because that's not included in our original problem. So what we have to do is, to account for that, we go ahead and subtract all of those numbers. We subtract the 1 plus the 3 going up to the 33. And that makes it to where it's the same as our original thing in the red box. But that's okay also, because what's great about that is that the second part, the 1 plus the ... going to the 33, we can use our formula for, right? It's first, it starts with 1, and it's consecutive odd numbers. It only has odd numbers that, we don't skip any, right? So it goes 1, 3, 5, 7, all the way up to 33. And because we have, and so then we can just use our formula like we have before, where we say this 2k minus 1 is equal to the 177, our last odd number, which we solve for k to get 89. 89 squared gives us the 7921. And we do the same thing for the second part here in the oval. And so we can say 2k minus 1 is our last number, the 33. And so that gives us 2k is 37, k is 17. And again, k is our number of odd numbers in this sequence, right? And remember that we're saying that n is equal to k squared. And so this gives us minus 17 squared. 17 squared becomes the 289. And then we just simplify these together to get the 7632. Erica, you've got a hand raised. Feel free to say what you gotta say.
Okay, well, I didn't get the same answer, but I used almost the same method. Instead of up to 33, I accidentally did up to 35. And I just minus the k's and then squared whatever I got.
So you did the k values, you subtracted those first and then squared.
Yes.
I see. Okay.
It was just easier for me.
No, I got you. Let's just think for just a second. So you got to be careful. That actually won't be the same thing in general, though, right? So you can check it with just these ones, like 89 squared minus 17 squared. That's actually not the same thing as 89 minus 17 squared, right? So you just have to be careful about that. Very good.
Thank you.
Mm-hmm.
Yes, just to write out in case that was a little. I know sometimes, when people talk math, it's kind of hard to get it up there. But that's what we're saying, is that in general, not always true, but for 99% of the time, two numbers you can't take that square out like that. It won't work out the same. All right, that takes us over time. So that's it for today. However, before you leave, please type your name into the chat again. First name, last name, and the word bye. And before we do that, can someone change the chat back to the public or everyone? So give us just a moment before you send that. Don't send it quite yet.
It's going to be the same for all the future sessions. We're going to take attendance before and at the end, just to let everybody know.
All right, sweet. And please make sure you're sending that first and last name to everyone, not just to any of us privately. That way we can see it afterwards and take attendance quickly and easily. That said, if you have sent your name, the first name, last name, and by to the public chat, you are free to leave. If you have any questions, please feel free to stick behind, and we can, handle that.
And we hope you all had fun. Remember, this is supposed to be fun. People do math in their spare time when they're bored.
Yeah.
Bye. Thank you.
Bye.
Thank you. Bye.
Thank you.
Bye.
It's every Friday, right?
Yes.
Okay. Thank you. Bye.
Bye.
Joshua, you're still on. Did you have any questions for us? Go for it.
So I got here late, and so I don't exactly understand a lot of what you guys were saying. So could you recap me on what happened?
Yeah, it might be very fast, but Connor, if you want to just go back to the slides, the main thing is we built up to the idea that if you're trying to find a perfect square, so let's say, yeah, cool.
Yeah. Okay. So like you said, it will be a quick recap. The idea was we start off with asking what's common in the following numbers. We came up with a few conclusions. The big picture is that they're all perfect squares, right? 4 is the same thing as 2 times 2. 36 is the same thing as 6 times 6. And then we said an integer n is a perfect square if n is equal to k squared. And we made a quick note that don't let the letter n scare you. It just represents an unknown number, right? And sometimes people will get a little like, woo, about letters and math, but it's okay. And specifically, we said that k needs to be a natural number. So 2 is okay, but something like 2.5 is not okay. So we want positive whole numbers, no decimals or anything weird. And then we talked about visualizing the perfect squares. And I'm going to hop through this a little bit, see how we just rearrange the circles and how some number like the yellow circles is 16. That's the same thing as 4 times 4. It's 4 across, 4 down. And then we were talking about organizing these a little differently. And so if we drew some lines in here, what we can see is that we have a group of 1, then a group of 3, then a group of 5, then a group of 7, and it would keep going if we were to keep putting down our numbers. And so what we see is that some number like the 16 here at the bottom, we have 16 is 1 plus 3 plus 5 plus 7, where we're adding consecutive odd numbers together.
And I was going to comment that this slide right here was the meat of today's presentation. So we had some warm up to remind ourselves what squares are, but really it's this fact that given any square number, you can actually write it as just all of the first odd integers up to a certain point added together. That was what all of our exercises was revolving around, was can I take a sum of odd integers and figure out what number squared that is? Or can I take a big number squared and rewrite it as a sum of odd integers? So this was the real key idea that the rest of the presentation focused on.
Yeah. And the fact that this is 4 and there's 4 pieces. And so that's kind of like the big picture of what today's session was. That also said, this entire thing was recorded, so you can go on and you can watch all of this in detail, because I know we're kind of like zooming through it, and some of it might be going straight in, some of it might be going right over. Yeah, and so then we were able to do this type of idea where we said 81 is a perfect square. actually, let's get a little bit more here. And so we said that with that idea that 81 would be the summation of 1 plus 3 going all the way to 17, and it has 9 pieces because 81 is 9 squared. And so, and then all the rest of the questions just built on that.
Do you have any like follow-up questions or anything that you'd like to ask about this idea?
No, thank you.
Of course.
Yeah, definitely check out that the recording though, because I mean you won't be able to answer questions while you're watching it, but you can at least get the same experience basically.
And you can pause it and do it yourself before we say it, before the video spoils it, right?
Yeah, no spoilers.
All right, bye.
Bye. Have a good evening.
Bye.